Okay, this next example is going to build off of a previous example, and this example will also illustrate, how roads are designed and engineered that we drive on every day. So one in particular is if you are driving from the East Bay and you're driving to Yosemite, there's a chance that you might come across this fork in the road. So it's on State Route 120, and there's a sign. If you're coming from, the Stockton Modesto area, and you're going east on 120, you'll see a sign, okay, that looks like this one, where it says Old Priest Road, take the right fork. And it's not labeled, but if you take the left fork, that is New Priest Road. Okay, so the right fork is Old Priest Road, and the left fork is New Priest Road. So you can see that New Priest Road, appears to be a longer route, and Old Priest Road appears to be a shorter route. And I took the data from these two routes, and the data that I got was the GPS coordinates. So GPS does, latitude and longitude, but it also includes elevation. So at the point where these two different routes diverge, where they fork, okay, that's the starting point. And so we have the starting point on O, which represents Old Priest Road, and the starting point of N, which stands for New Priest Road. And this will be mile zero at an elevation of 1,070 feet. And regardless of which of the forks that you take, you will end at this point, where the distance that you've traveled is different, depending on whether you took Old Priest Road or New Priest Road, but the elevation where you end up is the same, and that's 2,400 and approximately 60 feet in elevation. And from this point on, you just continue on to Yosemite. Now, in a previous example, the average rate of change or the slope of each route was calculated. And what you're seeing here in this graph is we have distance along either road and the altitude gain. So distance that you've driven on the road versus the altitude that you've changed. And you can see these dark dots here. That represents equidistant points along Old Priest Road. Okay, all the way to the end. So the starting point is here at a distance of 0 miles and an altitude of 1,070 feet. And as you go along Old Priest Road, then the relationship between distance and altitude fits on this line right here. And the average rate of change, or the slope, is about 750 feet per mile. So for every mile that you drive forward on Old Priest Road, you have an altitude change of about 747 feet. Now, instead of marking points along Old Priest Road, you do it on New Priest Road. And that's what the open dots symbolize, is distance and elevation at even distances or regular distances all the way to the end of New Priest Road, and you get this slope right here. So starting point, and up here is the ending point for New Priest Road. and that has a slope or an average rate of change of about 305 feet per mile. So every 1 mile driven forward, you've actually gone up 305 feet. So, that's the slope in feet per mile. But what's the difference between the slope of a road, the percent grade of a road? I don't know where that came from. The percent grade of a road versus its angle of elevation. These three quantities describe the same thing, but in three different ways. Now, percent grade is probably what you've seen driving on a road. If you've ever driven where there's a hill or a mountain, it'll tell you the percent grade. So this is how percent grade is calculated. Grade is also a ratio between elevation rise over distance run, but the units of elevation and distance must be the same. So percent grade is also a slope, but the units of rise over the units of run have to be the same. So up here, the units were different. We had feet for rise and miles for run. In order for us to calculate percent grade, they have to be the same unit. They have to be, either feet and feet or miles and miles, something like that. So in order to calculate percent grade on Old Priest Road and New Priest Road, the unit of miles needs to be converted into feet using this equivalence. So to calculate percent grade on Old Priest Road, we start with the slope, which is 747.39 feet per mile. And we want to multiply that by our conversion of 1 mile is equal to 5,280 feet. And what you get is miles cancels with miles and feet cancels with feet. And percent grade is what we call unitless. It does not have a unit of feet or miles or anything. It's just a percentage. So if you take 747.39 and you divide it by 5,280, then you get 0.14155, multiply that by 100, and you're going to get approximately 14%, right? It's actually 14.155 on percent. But when you're looking at the side of a road and you see a sign for percent grade, it just says 14% or 12%. It usually doesn't have a decimal place of accuracy behind it. Okay, so the percent grade for Old Priest Road is 14%. If you calculate the percent grade of New Priest Road using the same conversion, you get a grade of 6%. So confirming the calculation, the percent grade of Old Priest Road is more than 2 times greater than New Priest Road, consistent with the relationship between the slopes. All right. So, if we were to take New Priest Road and multiply that times 2, we get a 12% grade. And Old Priest Road is a little bit over 12. So that's where we get the percent grade is greater than 2 times that of New Priest Road. So, when you look back up here, you can see like Old Priest Road is shorter, but it's shorter because it's steeper. And it gets you from this elevation to this elevation faster. All right, so slope and grade describe rise over run. But where does the angle of elevation come into play with inverse trig functions? So angle of elevation, let me get rid of that. Angle of elevation is the angle under the hypotenuse of a right triangle. So let's look at the angle of elevation for Old Priest Road. So here is Old Priest Road. And if we make a right triangle with that slope of the road and this horizontal line, okay, which represents our starting altitude of 1,070, this forms a right triangle. And so of this right triangle, we have the slope of this line. It's 0.14155. Now, when we look at a right triangle and we look at the slope of the hypotenuse, well, we can take the inverse tangent of that slope, and that'll give us the angle of elevation. The angle of elevation is this angle right here. So that's the angle of elevation for Old Priest Road. So if we come down here, we want the angle of elevation of Old Priest Road. We need the grade of Old Priest Road. And if we take the inverse tangent of the slope, then we get an angle of elevation of 8.1 degrees. So the angle of elevation of Old Priest Road is 8.1 degrees. And we can do a very similar thing with New Priest Road. So here is the hypotenuse, and we can draw a line down to that same horizontal line of 1,070 for our starting altitude. That makes a right triangle. And the grade of New Priest Road is the slope of the hypotenuse. So if we want to find this angle of elevation for New Priest Road, we can just take the inverse tangent of that slope. So taking the inverse tangent of that slope gives us 3.3 degrees. And you remember that we said that the grade and the slope of Old Priest Road is greater than 2 times that of New Priest Road. And you can see that if we multiplied this times 2, we'd get 6.6 degrees, right? Which is just under Old Priest Road. All right. So, what we've done at this point is, we've calculated the slope, the percent grade, and now the angle of elevation of the fork in the road in State Route 120. Okay, and I was able to do it using the slope of those two roads. But how could inverse sine be utilized in this scenario to calculate angle of elevation too? So for this one, we're going to need the distance formula. But before I proceed, actually try and see if you can figure this one out on your own.